How do companies know a router is overloaded before users complain? How do network operation centers monitor hundreds or even thousands of devices in real time? Today I'm going to show you exactly how that works from the ground up. We are going to build a network topology in GNS3, configure IP addressing, enable SNMP, and then integrate everything with SolarWinds. Alright, now let's open GNS3. Once GNS3 loads, we are going to create a brand new GNS3 project. GNS3 lets us simulate real networking devices, routers, switches, firewalls, all without buying physical hardware. That makes it perfect for learning, testing, and building labs safely. I will give this project a clear name. You can name it however you want, and choose a location on your drive or on your machine where you're going to save it. And this is where you're going to find your project easily. Clear project name matters as well, especially when you're working in real environments with dozens of labs. Inside GNS3, we start by placing our devices. I'm dragging in 3 routers, 1 switch, and a cloud node, so we can connect this lab to our external environment. Now here is something very important. Topology design isn't random. Every connection represents a physical cable, an interface, and a potential failure point. So I'm carefully creating the network links between each device, making sure everything is connected logically and cleanly. This is exactly how engineers think in production. Next, I rename every router or every device clearly. In the real environment, poor naming causes confusion during outages. Clear naming saves time and stress. This step seems small, but it's a professional habit you want to build early. Okay, so now let's talk about IP addressing in a very simple term. An IP address is a unique identifier for a device on a network. Think of it like a home address or a phone number. No address means no communication, no monitoring, and troubleshooting. In enterprise environments, bad IP planning leads to overlapping networks, routing issues, and long outages. That's why this step is very critical. Now we configure IP addresses on all 3 routers. The process is straightforward. We enter interface configuration mode, assign an IP address, and enable the interface. I repeat this on each router, making sure the addressing is consistent and logical. Once that's done, we verify interface status and IP assignment. Then we test connectivity using a ping. Here's a rule experienced engineers live by. If you can't ping it, don't move forward. Monitoring only starts with basic connectivity. Now let's break down SNMP. SNMP stands for Simple Network Management Protocol, but here's a simple explanation. SNMP lets devices report their health information like CPU, memory usage, interface traffic, and device uptime. Without SNMP, monitoring tools like SolarWinds are completely blind. So on each router, we enable the SNMP service, we configure a community string, and allow the monitoring server to query the device. A community string is basically a shared password. In production environment, SNMP v3 is preferred for security. However, SNMP v2 is simpler and commonly used in lab environment. One matter is understanding how monitoring communication works. So companies rely on monitoring tools like SolarWinds to maintain visibility. But SolarWinds doesn't magically see devices. It depends on proper network design, correct IP addressing, and SNMP being configured correctly. Now we move into SolarWinds, post-configuring IP addressing and SNMP. From the SolarWinds console, we access the Network Discovery wizard. Here we provide the device IP addresses and the SNMP credentials we just configured. Once that's done, we allow SolarWinds to discover the devices on the network. SolarWinds then discovers interfaces, starts pulling metrics, and builds dashboard automatically. This is exactly what real NOCs rely on every day. After discovery complete, we add the discovered devices for monitoring. Now we check the device list and review available resources. Within minutes, we can see CPU graphs, interfaces, traffic, and availability status. We open the device details page and view the live polling data. This is real monitoring, not theory, no screenshots. This is what production environment looks like. If SolarWinds doesn't show data, don't panic. Troubleshooting follows a logical flow. Can we ping the device? Is SNMP enabled? Is the community string correct? Is anything blocking traffic? Great engineers don't guess. They verify one layer at a time. If this video helped you, like and subscribe. It really supports the channel. Comment below what should we monitor next. I will see you in the next one.